In the last section, we covered 1- and 2-step conversions in the SI system. In this section, we amp it up a little bit and we cover non-conventional units, mostly derived units. For example, we start with conversions involving area. Now, the first step in understanding area conversions is remembering where area comes from math class. Now, the equation for area, it differs depending on what the shape of the object is, but we start with the simplest shape, a square or rectangular space in which the area is the length times the width of that space. That for this particular box, we'll assume that this is a square that measures 1 meter on each side. So to calculate the area of this box, area is length times width, or 1 meter times 1 meter. Now, meter times meter is meter squared, and 1 times 1, following the same logic, is 1 squared, which is just 1. If we look at this exact same square from a slightly different point of view, each side that was 1 meter is also 100 centimeters. If we substitute that into the same area equation, area is 100 centimeters times 100 centimeters. This comes out to centimeter times centimeter, or centimeter squared, and 100 times 100, or 100 squared. Now, the 1 squared in the first one just becomes 1. Here, the 100 squared could become 10,000. But I choose to leave the squares and write it out another way. In each situation, this is the exact same square. Whether it's measured in meters or centimeters, it's still the same. That means the two areas we calculated are equal to one another. Or 1 squared meter squared from here is equal to 100 squared centimeter squared from over here. Now, the reason why I chose not to write it as 1 meter squared equals 10,000 square centimeters is this. We can see a relationship that we're familiar with. 1 meter is 100 centimeters. And it's written here, 1 meter is 100 centimeters. When we are working with squared units to convert, we take the conversion factor and square every single part of it. So 1 meter is 100 centimeters, you square it, you get this. But it also means that this works for any unit at all. For example, 1 meter is also equal to 1,000 millimeters. And we can square that, and we get 1 squared meter squared is equal to 1,000 squared millimeters squared. Now, using these as a conversion factor is not as difficult as it might look at first. We have a few examples up here. In the first example, we're dealing with square meters and converting it to square centimeters. Like every other problem, we start by writing the given as a fraction. Followed by our conversion factors. Here we know how meter squared and centimeter squared relate. It's based on 1 meter is 100 centimeters. But meters squared is not going to completely cancel with meters. So, we square each term. Now meter squared cancels. Also, the 100 squared can become 10,000. And we're left with this times 10,000. So our final solution is 43 square centimeters. 2 significant figures to finish with because we started with 2. Next example is exactly the same, but we reversed it. We're going from centimeter squared to meter squared. Begin with 153,000 square centimeters over 1. We want centimeters to cancel, so this time it goes on the bottom with meters up top. 1 meter, 100 centimeters. Square everything. Centimeters cancels. 100 squared is 10,000. And solving the problem, we get 15.3 square meters. In the last example, we now look at millimeters squared and meters squared. Begin with 0.00632 meters squared over 1. Meters on the bottom so that it goes away, millimeters up top. 1,000 millimeters in 1 meter, squaring everything and canceling meters squared. 1,000 squared is 1,000,000. That gives us, for an answer then, 6,320 square millimeters. And we're done. We can take the same idea, the same premise, and apply it to volume. The simplest formula for volume is volume for a square or rectangular box at V equals length times width times height. So if we assume this box measures 1 meter by 1 meter by 1 meter, substituting in for the volume, we get 1 meter times 1 meter times 1 meter. Meter times meter is meter cubed. 1 times 1 times 1 is 1 cubed. If each of these sides is 1 meter, then it's also 100 centimeters. And substituting in 100 centimeters times 100 centimeters times 100 centimeters is centimeter times centimeter times centimeter, centimeters cubed, 100 times 100 times 100, or 100 cubed. Now, leave these alone. We agree that this is the exact same box, no matter what unit we measure it in. So that means that these volumes are equal to one another. 1 cubic meter cubed equals 100 cubic centimeters cubed. Where does that come from? Still 1 meter equals 100 centimeters, but if we are using cubed units, you have to cube everything. Likewise, 1 meter is also 1,000 millimeters cubed. There is one more relationship that will come up with volume conversions, and that is we don't always work with the cubed units. Sometimes we use liters or milliliters instead. So remember this one relationship. This came from the SI presentation, and it is 1 milliliter and 1 cubic centimeter are the same thing. Make sure you memorize this. It will be used in the rest of our conversions. 2 examples of conversions in volume. The first one, start by writing the given as a fraction. We are getting rid of meters cubed, so that goes down here, and we're switching to centimeters cubed up top. Put in our numbers. 1 meter is 100 centimeters, but since it's cubed, I cube all terms. Meters cubed and meters cubed cancel. 100 cubed is 1,000,000. And this times 1,000,000, 75 centimeters cubed. And as always, double check your sig figs. 2 and 2, we're good. In the next example, centimeters cubed to milliliters, we use the relationship I just gave you, and it says that cubic centimeters and milliliters are the same thing. So if they are the same thing, then our answer will be the same. So why even do any dimensional analysis? The answer is dimensional analysis is not just about numbers, it's about working with units. So we try to set up everything in a way that the units cancel. So we have 0.0037 cubic centimeters over 1. That's the given. We are getting rid of cubic centimeters, that goes on the bottom. Convert 2 milliliters, that goes up top. And if they are the same thing, 1 milliliter is 1 cubic centimeter, but cubic centimeters cancel out, and that's why it's worked into these conversions. That means we have the exact same number, 0.0037. However, the unit changed to milliliters. Okay. This is a basic plan that's used to solve all of the volume conversion problems we'll be looking at. This plan can be modified. We can, on this side, convert from cubed units to other cubed units like cubic decimeters or even cubic kilometers if we wanted. On this side, liters can be converted to things like kiloliters, centiliters, milliliters. Well, not milliliters because we already came from there, but it can be converted to any other liter-based unit. Now, we can write this with the arrows pointing in both directions, showing that we can go this way through the chart or this way through the chart. All that's important is that we find what we're starting on and keep going until we get where we need to be. In this problem, we are on meters cubed, and we're supposed to be on liters. So that means we have 1, 2, 3 conversions. When we set this up, 15.6 meters cubed, we'll follow by 3 conversion factors. First conversion factor involves just cubic meters and cubic centimeters because we're going from here to here. So the meters will be on the bottom, centimeters up top. Again, 100 centimeters per 1 meter. This has to be cubed, so cube all terms. Meters cubed cancels. And in your next bracket, we're getting rid of cubic centimeters, but we're going to milliliters. So cubic centimeters on the bottom, milliliters up top. 1 cubic centimeter is 1 milliliter. Cubic centimeters cancel. And in your last step, milliliters goes to liter. Milliliters on the bottom to cancel, liter up top. We can write this as 1 liter is equal to 1,000 milliliters. Milliliters cancels. And with the 100 cubed, that's a million. We could cancel these zeros with 3 of these zeros, and we have 15.6 times 1,000, or 15,600 liters. Do a quick count of significant figures. 3 here, 3 here, all our rounding is good. And we continue on. Now, when we put this all into a word problem, there's a few steps we should be doing. First step is always write out the information you're given and what you're asked to find. So we're given a rectangular box with a length of 75.0 centimeters, a width of 250.0 centimeters, and a height of 100.0 centimeters. We're asked to find the volume of this space, but it's worded as how many liters of water could this tank hold. So we're looking for the volume, but in liters. So step 1 is volume equals length times width times height, or 75.0 centimeters times 250.0 centimeters times 100.0 centimeters. With a little bit of math on the calculator, we have 75 times 50 times 100. We get 1,875,000. Looking at sig figs, I have 3, 4, and 4, so only 3 in the answer. This becomes 1,880,000 cubic centimeters. It's asking us to find this in liters, so from the basic plan, we take centimeters cubed, convert it to milliliters, and convert that to liters. So that volume becomes the given. And if we're going from cubic centimeters to milliliters, our first bracket has cubic centimeters and milliliters. substitute in the numbers since they're the same thing. It's 1 and 1. And now I'm getting rid of milliliters and going to liters. Milliliter on the bottom so that it cancels liter up top. 1 liter is 1,000 milliliters. Milliliters cancels. I also can cancel those 3 zeros with those 3, and my answer is 1,880 liters. So one more to practice on. From liters to cubic meters, this uses the entire plan, but in the reverse direction. Liters will be converted to milliliters, to cubic centimeters, to cubic meters. 0.065 liters over 1 times 1, 2, 3 brackets for 3 conversion factors. First one is liters to milliliters. I want liters to cancel, so it's on the bottom with milliliters up top. My numbers are 1,000 milliliter per 1 liter. And we move from milliliters to cubic centimeters. To cancel milliliters, it goes down the bottom. Cubic centimeters up top, and it's 1 to 1 with milliliters canceling out. In our last bracket, we're going from cubic centimeters, so I'll put centimeters here, meters up top. 1 meter is 100 centimeters, but this is cubed, so everything becomes cubed. That way the cubic centimeters cancel out. This 100 cubed becomes 1 million. We could cancel 3 of those zeros with 3 of those, and we're left with 0.065 divided by 1,000. That's 0.000065 liters. Okay, looking at this number, it's really important to have a little bit of confidence in your math. And the reason why this number is completely correct, but a lot of times we psych ourselves out when we see a number that we don't expect, a number that's either larger than we're expecting or smaller than we're expecting. Because I have 0.065 here and 1,000 here, but a million underneath, it's going to come out to an even smaller decimal than we started with. That's normal. It doesn't mean that any of these are wrong, but if you don't trust your number, don't assume it's wrong. Just go back and double check. Milliliters are smaller than liters, so you should have a lot of them in 1 liter. Centimeters are smaller than meters, so it should be lots of centimeters in 1 meter. As long as that checks out, we are good. Continuing with our unconventional units, speed conversions. This particular problem, we begin with kilometers per hour and we're asked to switch to meters per second. Now, I want to look at how we set up the conversion, the first bracket, before we talk about the plan, because it'll help you see the plan better. I always give you a rule of write the given as a fraction. Although I sometimes say that you can put a number over 1 to make that happen, that's not always the way we do it. That's one of the ways we do it. This one is already actually a fraction. It's just not written as a fraction. So it's 80.0 kilometers per hour to meters per second. That's 80.0 kilometers over 1 hour. Our plan is kilometers per hour, and you can only convert one thing at a time. So you have to decide, do you convert kilometers to meters first, or do you convert hours to seconds first? I use kilometers to meters only because it's a one-step conversion. So I'm going to change kilometers to meters. That's my one thing that's changing. I cannot change the bottom yet, so it still stays hours. And if I were to solve the problem here, I would be in meters per hour. Then I start converting the times. Keep meters, but change hours over to minutes. And in the last step, change minutes to seconds. Our conversion factors are based only on what's changing. So the first conversion factor is based only on kilometers and meters, second one on hours and minutes, and third one on minutes and seconds. In the first bracket, kilometers is what we're getting rid of, so it's on the bottom. Meters on top for what we're going to, and it's 1,000 meters over 1 kilometer. Kilometers cancels. In the next bracket, hours is going to minutes. So hours is on the bottom. If I want hours to cancel, I have to put it up top with minutes on the bottom, and that's 1 hour is 60 minutes. Now the hours cancel. To get rid of minutes and go to seconds, minutes must be on top with seconds on the bottom, and it's 1 minute is equal to 60 seconds. Minutes cancel. A little bit of math to do here. We multiply across the top, we multiply across the bottom, and we divide the top by the bottom. And we keep 3 significant figures because that's what was in the given. So when done, the answer becomes 22.2 meters per second, because those are the units not crossed out. It also matches up with what we're asked to find, so we're done. In the next section, we will look at density.